So we will have coming up talking about infrastructure as code on AWS, a deep dive on that from Amazon Web Services. We have coming up Darko Mesaroš.
And welcome to my infrastructure as code deep dive talk. This is a lovely talk from my room, my office, and I'm going to be talking about a few things today with you, mostly focused around infrastructure as code. So this is a relatively deep dive topic. I'm not going to talk about the basics. I'm going to talk about some best practices, some methods, some things you should do when you do infrastructure as code. Well, on any platform in general, but I'm going to be focusing on AWS a bit more. So who am I and why should you care? My name is Darko Mesaroš. There's a few ways you can write my name, depending on which country you're from. But I come from Serbia. And one fun fact about me is that I've changed 5 countries in the last 8 years. So I moved from Serbia to Czech Republic, to Malta, to Ireland, to Germany. So, now actually in Germany, I live in Berlin. And yeah, I'm streaming this line from Berlin. So yeah, fun times. I work for AWS as a developer advocate or a senior developer advocate. So I'm a person who talks to you, gets your feedback, and puts it back to some proper people who should listen to it. You'll also get to see me on a lot of different events as well. So let's get started. So this is a session 300. What is a session 300? So this is what we like to call an advanced topic. So I will not talk about the following things. I will not be talking about infrastructure as click. I will not be talking about why should you use infrastructure as code. I will not be telling you how do you do infrastructure as code. I will absolutely not be comparing infrastructure as code tools because let's not start religious wars, right? So what will we talk about then? Right? So what is going to be the talk of our talk? Of today's, and be ready for a lot of terminal screenshots. I hate slides, but I like to show code, so I kind of implemented my terminals inside of my slide deck. So get ready to see a lot of terminals. So here's a story about a person. So this person is an engineer. This person is somebody who deploys servers, somebody who deploys infrastructure, be that in a relatively traditional data center or in the cloud. Which cloud doesn't really matter, right? So how can we make this engineer's life better, right? So I used to work in a company, I think like 6 or 7 years back, where I would deploy servers. Now, I wasn't physically on location because our data centers were all over the world. I wasn't plugging in the servers directly, patching and putting all the cables in, but I was the guy who was configuring them. So basically, a guy would call me up, hey man, I just attached 400 servers for you. Go at it. Here are the IP addresses of their remote interface adapters. I would go there and just run a bunch of commands, do a whole lot of things, clickety-click. Was not too fun, right? So it took a lot of time, a lot of racking and stacking, a lot of back and forth. But things have moved on since then, right? So how do you provision infrastructure right now? How do you provision infrastructure in the cloud? Well, like this, right? We have replaced our racking and stacking, our cabling, our clickety-clicks with some code, right? We have took in some code. We have a piece of code that does something, creates our infrastructure, and wow, a lot less cables, a lot less back and forth calling. We can do it all from the comfort of our rooms, right? So we have a piece of code. We have our infrastructure, which is a piece of code. What should we do with it? We can just take this. We can put it in any. Well, in this case, we're talking about CloudFormation. I can take this piece of CloudFormation code, give it to CloudFormation, say, here you go, launch my infrastructure. Simple as that. But we can do better. We should actually take it through a pipeline, right? So a lot of people take infrastructure as code for granted. They think, oh, this is just another tool that helps me. Instead of clicking, I can just provision my infrastructure. No. Use infrastructure as code. Take all the best practices, all the elements you do when it comes to application development and delivery, and apply it to infrastructure as code, right? So don't just give it to CloudFormation and hope for the best. Use a proper pipeline. Use testing. Use building. Use different environments. Take it through what people call a CI/CD pipeline, right? Have a workflow. Have a way to kind of implement this inside of an architecture or get your developers that code, right? Write your infrastructure as code in a language or a template of your choice. Commit those things to repositories. It's very important that we keep our templates, our pieces of code that define our infrastructure in proper repositories. Give them versions, right? Keeping these things in repos gives us the ability to do versioning because, well, having a version 2 of your infrastructure sounds like a big thing. Test. Keep testing. Use all the testings you can do to test things because nobody wants to deploy a bad piece of infrastructure to the cloud, right? A friend was telling me he was doing some upgrades on an OS. He was running a Ruby application and he did some upgrades in his infrastructure by changing the OS stuff. And one of the things that wasn't apparent is that a different version of the OS uses LibreSSL instead of OpenSSL. And that broke his application, right? It's not something that you see out of the box, but once you test it out, it will launch perfectly, but your application will not work. So make sure if you make changes to the infrastructure, you actually fully test it, right? Get a sip of coffee there. And finally, deploy. Properly deploy. Deploy to testing, deploy to staging, deploy to development environments, and finally, deploy to production. But one thing is important here. This doesn't work in itself. Having just, a little pipeline or workflow like this doesn't work. You have to repeat, right? Most important of all, keep repeating. Get the values up, get the information, get the metrics, get the information, what you did good and bad, get the feedback, rinse and repeat. So, yeah. Okay, speaking of delivery, let's talk about delivery of CloudFormation. So, just quickly, CloudFormation is our infrastructure as code tool. It's the one built on top of AWS. It's a piece of code, or it's a service where you give it a YAML piece of code or JSON if you're a robot. You put it either locally or put it in an S3 bucket, give it to CloudFormation. CloudFormation makes a whole bunch of API calls, and those API calls get turned into AWS resources, right? So that piece of code looks very simple. It's written in files that are called templates. Who would have thought, right? I said you can do JSON and YAML. It creates these thing called stacks. The stack is this grouping of resources, right? And these resources kind of define the resources define a specific setting of an actual resource within AWS, right? You can create most resources on CloudFormation. Not all of them are supported. As we grow, sometimes a certain feature is not supported on CloudFormation, but there's ways around that, right? There's a couple of things you can do on CloudFormation today to create even third-party resources. So if you want to create like a GitHub repository, you can do it today from CloudFormation, right? So it's very cool. And that's how it looks. Like, this is the same copy of my CloudFormation code I use in one of my beginning slides, and and it also kind of handles the dependencies from time to time, right? So it understands what comes before what. So if you create an instance profile and then an instance that uses it, it will automatically create that instance profile first, then the instance. Sometimes that doesn't work. Sometimes you have to explicitly declare dependencies. So be mindful of that as well. So best practices. Right? That's people ask me this. So what are the best practices for CloudFormation, or what are the best practices for X, Y, and Z? That really depends, right? So what are you doing? But some of the things I can really advise you, right? So one of the first best practices I need to say, start in the code editor. So no matter which code editor you're using, be that Visual Studio Code, be that Vim or Emacs or a Notepad, doesn't matter, right? Anything you use that can have the proper tooling, you should start with best practices there, right? So if you're using something like VS Code, you can use some linter tools such as CFN NAG, right? Linters are these tools that can help you detect problems early on. As you're typing them, you can see, hey, I might have a problem with my syntax here, or what I'm doing here is not maybe the best practice. As you can see on the screenshot here, it will say, hey, warning, your security group is opened to all, right? Those kind of things. So it might kind of pinpoint those things. Additional tool here, as you can see here, is CFN NAG. Now, CFN NAG is a tool made by Stelligent, and it's a tool that basically detects insecure patterns within your infrastructure. The same as before. You see on the screenshot, a console shop, it sees there's a failure in my template. As I ran it through CFN mag, it says basically an IAM role has an allow action for all. That's a security problem. You should fix that, and it will not allow you to proceed unless you have fixed that. It will also show some warnings, right? It's allowing ingress for multiple IP addresses, which is not just a single IP address, right? So those kind of things, and you can run this against one or multiple templates. You could it's a command line utility where you just pass it on, saying, hey, you know what, I've written my CloudFormation template, check it out. But you can also bring your own rules. So you can create your own rules that you can take these things and build on top. Like you can, for example, you might want to prevent a certain, image being used or a certain something being like an insecure thing for you, right? So it's really up to you how you can configure them. And it's open source, right? So how do you install it? Gem install cfn_nag -- user. And away you go, right? You can start immediately by using it. Now, moving forward, one of the other tools, which I kind of mentioned a bit before, is CFN lint, right? It's built in. You can attach it into like VS Code as a plugin, but it's also a command line utility, absolutely, right? So it's a code linter made by AWS for CloudFormation. So it lints, it kind of validates CloudFormation templates, right? JSON, make sure that you're using valid resource properties, and it also, allows you to test a template for a given region, right? Because some regions might do things differently, and you'll see that a bit later on. So you can define some of the tests directly within CloudFormation templates. So when you run CFN lint will pick up on things when you execute them. And again, to install pip3 install, right? CFN-lint -- user, simple as that, and you can go ahead. One of the things, let me just click here properly. Yes, cool. Lint twice, deploy once. This really means that I want you to lint as much as possible and then deploy, right? Use linters. It's free, right? It's cheap to do it there. Like in this example, you can see me actually linting my template against two different regions. So, for example, in the first one, we just get warnings, right? So I have hard-coded availability zones. In the second one, it actually throws me an error. You must specify a valid resource for T2 micro, because I'm using the EU North or the Sweden region, which does not have T2 instances, has T3 only. So my stack would automatically fail if I would try to launch it in Sweden, but it would work, for example, in Dublin. So these things save you, 12 clicks and waiting on that CloudFormation dashboard, so it just fails. So it's a pretty neat tool. It doesn't test everything, of course. A lot of things to test in CloudFormation, you get problems because you don't know if it works unless you actually try to deploy it, like limits and those things. So CloudFormation does not know them until it tries, right? Or maybe some conflicting things. So some of the things we need to, if we want to test something, we actually need to go through a deployment process. And how do we do that? Well, glad you asked, right? So there's a tool up there also made by AWS called taskcat. Taskcat is a tool that basically tests CloudFormation templates by deploying them, right? So it uses also CFN lint out of the box just to do some basic linting. But what it does, it takes your CloudFormation template and deploys it to a specific region with a specific parameter set, and basically sees is it successful or not. So if it is successful, it will spit out like a report. Well, actually, no matter what it does, it will spit out the report. But if once it launches it, if it's successful, just terminate the stack in itself. So in general, it has all of these functions in it. And just to install it again, our lovely friend pip3 here, I install taskcat -- user, and you can use it. So one of the things you need to have on it is this taskcat test. It's a file called .taskcat YAML file. This is where you actually define your tests and projects. As you can see in this case, I have defined regions, some parameters. You can also do something like blacklisted AZs, so it will prevent specific AZs to be used during deployments. But in this case, like I'm trying to deploy my stack in US West 2 and EU North 1 with some different set of parameters but I'm using the same template, right? So it will deploy it. It will just go to this. It will lint to my template first. So it will, as you can see here, a couple of lines says lint passed. So it actually did some linting. And then it will deploy. It will show create in progress, and it will go through all of that to deploy my template. And if it is complete, I will get something like this. This is a really nice HTML report that basically shows me, hey, you know what? These are all the events that happened. Your resources were created properly, etc., etc. So it gives us that. If it fails, of course, it fails. It gets deleted. Think of this tool. So, for example, in Amazon, we have this thing called quick starts. So quick starts are a massive collection of CloudFormation templates. And these CloudFormation templates are being used by a lot of people. So what we do is basically we constantly spin them through taskcat, getting them to be tested, right? So it all works constantly, and that basically people who use it will not fail for some reason. So imagine you having a collection of CloudFormation templates that you use for various different parts of your infrastructure. You want to make sure that they work no matter what. So if a new feature is released, if something is deprecated, etc., you want to make sure that CloudFormation can be launched when it needs to be launched, because you don't want to test when you need to roll into production. You want to test way before that. So by constantly deploying CloudFormation templates in a limited form, right? Maybe with a smaller set of instances, you will ensure that this CloudFormation still works, right? You don't want a stale CloudFormation template that was written 7 years ago and nothing works. So how does this all fit? So if we take a massive step back here, right? So how does this all fit? So looking at CloudFormation like a full CI/CD pipeline, how this would all look, ideally, at the end, we have something from source where our developers with their proper IDEs would, put some plugins, do some linting locally, write templates, push them to a Git repository. That Git repository would go into a pipeline. On your first build phase, you would, run some linting, maybe CFN lint and CFN nag. Then you would run a test, such as taskcat, where you would actually deploy it in a test environment to see if it works. And then later on, you would basically promote it to either staging environments or actual production environments. So this is how a full-fledged AWS CI/CD pipeline for CloudFormation would look, right? Now, let's talk best practices, right? So some of the things must be better than others. I show some tools which are cool and are great, right? But let's talk about some of the best practices when it comes to CloudFormation delivery, or CloudFormation in general. A lot of these things that I talk about here are not CloudFormation specific in general, especially on this slide, but they apply to basically any kind of infrastructure as code you do. First thing is first, make sure to layer your application. So that means if something actually goes wrong, that you can reduce the blast radius, right? So if you make a change to a certain EC2 instance, you don't want that a single failure or some bad configuration parameter that you have not caught in your testing to mess up the entire stack. Absolutely use multiple environments, right? So isolated environments, different AWS accounts, for testing, staging, development. Be sure to do that. Do not, deploy to prods out of the box, right? Do not commit to your master branch and do not deploy to prod. So make sure to create like smaller files. Of course, a lot of people like to do this big old CloudFormation template that does everything, but maybe make it a bit smaller. Maybe compress it down to something that will make a lot more sense for you to see, understand what it's doing. Give it some more. Let's say, give it a purpose, right? Give it a specific purpose and not make it a jack of all trades. A couple of things regarding CloudFormation. These are CloudFormation specific. Use resource import to stack refactoring. So if you want to move a resource from one stack to another, right? This used to happen where people would, I want to move my database from one stack to another, but it's not possible. I don't want to terminate my database because a lot of data. I don't want to, it's a migration effort. So one of the things you can do here is stack imports or resource import, which is a feature from CloudFormation where you can actually import one existing resource to a different stack. Once it's in that stack, you can delete the old one. The resource will stay within the new stack. And also the same thing comes for like drift detection. Drift detection works on some resources. Not all of the resources are supported, but you're able to detect if something has changed. Some resources have drifted from their original configuration. So, for example, in this case, like a network interface you see here, we expect that it has an associated public IP address, but it's not there. It was removed manually. So, like the delete on termination setting for an EC2 instance was added later on. So these things are different, and you can actually use resource import to re-import that resource into CloudFormation to fix this drift. Or, well, if you want to accept this drift, if you want to just go with it, you can just import the existing resource back into the CloudFormation template to kind of fix it all. Last but not least, parameters. And this I need to mention the last thing first, but it's something that it's a very, very obvious thing. Do not hard code sensitive information. There's been a lot of times people will hard code passwords and sensitive data, database keys, whatnot, into CloudFormations. Don't like you don't do it in application code. Don't do it in infrastructure code. It's the same thing, right? But use something like parameters, right? Use parameters when you pass a parameter during the creation of a stack for sensitive information. Or if you want to do something like, for example, an instance type or an AMI ID, you can use mappings. Mappings are just, it's a matrix where you can choose a value depending on some other value. And you can like map a specific AMI to a specific region, so you can use a single template in multiple regions. And for an actual best practice, if you want to secure like a database password or a secure key, you can use Secrets Manager or SSM Parameter Store, where you can actually store those secrets or those passwords, those critical information, and reference them. Like in this case, you can reference them directly from CloudFormation templates by invoking that thing from Systems Manager. So that's a supported feature of CloudFormation, which absolutely should be used, right? Even for things like if you want to get the latest AMI from Amazon, there's a global SSM parameter store where you can reach out in a similar fashion like this. So pretty cool, and I think it should be quite useful for a lot of people. Okay, moving on from delivery of CDK, right? So we're going to talk about CDK. So CDK, or Cloud Development Kit, again, it's an AWS thing. So why CDK? Why? I mean, I said I'm not going to say why not. Why? I'm not going to talk about why IC, but why CDK? Well, if you hate JSON, like a lot of people, or if you hate the tabs in YAML, right? So it's you may want to do something else. If you're not comfortable with writing your templates within JSON, YAML, or you want to use your existing language experience to write your infrastructure as code and not rely on writing a bunch of Python scripts or all those things that kind of are a bit clunky. Well, CDK is this basically a multi-language, a generic language development framework. Basically uses things such as Python, JavaScript, and TypeScript, Java, and C#. It uses them to create your infrastructure. Now it's built on top of CloudFormation, so the end product is still CloudFormation, but this helps you abstract all of that. So you take your CDK code. In this case, you see it's JavaScript. Yes, JavaScript. It takes this JavaScript code and converts it to CloudFormation, right? But you can use all the programming best practices such as looping, reading off disks, etc., etc., etc. So it kind of becomes a lot more approachable than just using plain old YAML or JSON. So how does this work in CDK, right? So there's a couple of elements, constructs. This is the code you write. This is where you define your apps, your stacks, and resources. So an app contains one or multiple stacks, and one stack contains one or more resources, right? So resources be your infrastructure, like an EC2 instance, database, whatnot, right? All of that is being taken by the CLI. The CLI is the core of the tool. You cannot work without it, right? Takes that, it converts it, does a lot of magic to it, converts it to templates, right? Converts it to CloudFormation, and then it actually deploys it to CloudFormation, and CloudFormation does all the API calls. So CDK itself does not directly make API calls to AWS for resource creation, but it uses CloudFormation at the end, but it simplifies things so much, right? Again, main components, the core framework, the thing which you work with. A lot of people kind of tend to skip over these things. The core framework, basically where you define your app stacks and resources. The construct library, right? So this is where you have a specific AWS construct. For example, if you create an S3 bucket or a DynamoDB table with a construct, it's a bit more, let's say, opinionated then you would do it through CloudFormation because there's a lot of defaults set already. But I'll talk this later on. And finally, the CLI, yes, the glue that fits it all together is the main component of this, is the thing that you use to interact with CDK code. So constructs, right? So there's a couple of constructs approaches to CDK, right? So we have CloudFormation, AWS services, and design patterns, right? So these are, let me actually go, I'll talk about more about these in the later slides, but you can do some typical simple CloudFormation, already existing CloudFormation options. You can do services, which I mentioned before, like S3 or DynamoDB, some specific service constructs, or design patterns, which are opinionated reference architectures, right? So it uses multiple AWS services. For example, if you want to create like in this case, application load balance Fargate service, it will create all the things you need to create the Fargate service, right? So in this case, it will generate that little 5-line piece of code, will generate 817 lines of CloudFormation code that will create VPCs, load balancers, Fargate services, task definitions, blah, 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 right? So it's a very opinionated way to do these things. So, but let's go through each of them. So here's an example. This is a CloudFormation resource construct. CloudFormation resource construct, and a lot of people don't know this, you can actually literally use CloudFormation resources within CDK with the same set of parameters, same set of options. Like in this case, I'm creating a VPC with a CIDR block, and yeah, it will create myself a VPC, just a VPC with CloudFormation. Simple as that. Well, it will use CDK to create that into CloudFormation, but it's using this specific syntax for CloudFormation resources or CloudFormation constructs. Now, moving on to constructs or service constructs, we're doing the same thing. We're creating a VPC here, right? I'm just using a slightly different code. There's no CFN in front of VPC. And I'm defining the same thing, calling it my VPC. I'm doing same CIDR range and everything. But when I create it, there's a bit more things. I create an elastic IP address. I create an internet gateway. Some metadata is created. So it's a bit more opinionated. So it creates a lot of different things, not just the VPC, but because this is the way it should go forward, right? So a bit different, right? And the last thing that I mentioned that pattern or basically these are the big boys, right? So these provision a lot, much more things. In this case, like I'm creating the application load balance Fargate service that creates, with just these few lines of code, it creates a whole lot of different things, right? So in turn, it creates, from load balancers to ECS services to Fargates and a whole lot of VPCs, and you just get an output, and there you go. You have your ECS load balanced Fargate service ready to go. So how do we prevent mistakes? We don't like seeing this in our code, right? Seeing this thing is a pain, right? Especially if you have to wait for a while. Luckily here I waited for just a couple of seconds, or not even a second, because I busted something in my code. But how do we test, right? I mentioned some testing tools, some testing utilities in CloudFormation. But how do we do with CDK, right? What can we do here? We can take a sip of coffee, and then we can talk about testing. So how do we do testing on CDK? Well, there's like 3 testing approaches you would do here, right? Snapshot tests, fine-grained assertions, and validation tests. We do all of this with Jest. So I'm using JavaScript or TypeScript in this case, and we use Jest basically here and the assert framework from CDK. So we're going to be using Jest as a utility here. So what are snapshot tests? Well, let me get into it. It's going to be easier for me to show you than talk about, like, maybe it will make more sense. So talking about snapshots. So what are snapshots? Let's say I create something in my CDK. Let's say I create a dead letter queue, a SQS message queue I created, and how can I define a snapshot test for that? So this is how my test file looks. So this is basically a dead letter queue test file for myself, where I say test, I call it a name, right? But I expect here that my CDK output matches this template. So when I run my test first time, right? So if I would run this, I would basically get a snapshot created. It will always pass. So I will get the snapshot file, which is in the __ snapshots directory inside of my test folder. And I will have this snapshot of my infrastructure in time. And from then on, all my tests are based off of that snapshot. So if somebody makes a change to my CDK, and it doesn't match in my snapshot, it will fail. So, and that snapshot looks like this. It's basically a kind of it's a version of a CloudFormation template. It looks a bit different, but yeah. So if I make a change now in my CDK code and run my test again, it will fail because my new change does not match what it's expected, right? It does not match my endpoint, well, my snapshot. And to kind of go over this, if you want to fix this, you can just run the npm test -u command, which will update the existing test to the current snapshot. Oh, well, actually, it will update the existing snapshot to the current state of the snapshot. So you can kind of, go over the test or avoid the test all in all. So, but it's a great way to get a fast way to set up simple testing, just so you're sure that you do not break things. So, but I want more functional control. I don't want just to kind of have a blanket statement saying I want my CDK output to be X, right? I don't want to say that my CDK output needs to just match a certain thing, right? So what we can do here, we can expect things, right? Let's set some expectations, right? Let's do this. Like this test in this case represents that it is an expectation of certain resources and its configuration, right? For example, in this case, I expect that my dead letter queue that's being created by my application here or by my CDK stack, I expect that dead letter queue has a CloudWatch alarm that is configured in such a way. So we have specifically defined my task will pass if this dead letter queue, once it's created, has this specific resource in it. So, you can see here, or for example, a second test, we are expecting that this resource has a specific parameter or specific property, like message retention period, set to a specific value, right? So once I have done these tests and run the npm test again, these tests fail. So it has not passed, and it basically you can see here that it expects a specific resource to have a specific parameter or to have a CloudWatch alarm. So you can see here that it has failed. And to remediate this, I cannot just do npm test --u. I really have to go and fix this. So the same as we would approach software development, we could do it here. We can write our tests first. We can set our expectations within tests, and then we can just code on top of that and make our application code match our tests, like proper test-driven development. Now, going further just a bit, I mentioned validation checks. I'm not going to show them here, but validation checks are something that are more common to just general programming practice. It has nothing to do with a testing framework. But for example, let's say the message retention period in this case, I could state inside of my application code, inside of my CDK code, let's say that the message retention period must be between two values. And if you pass it a different parameter on top, it will fail. Right? So those are kind of the validation tests that you can run within your application code. Those things can also be integrated with Jest to an extent, but yeah, that's kind of the gist of it. Okay, last but not least, I want to mention, I mentioned this before, that you can kind of do things in CloudFormation like GitHubs, maybe something else, right? So CloudFormation registry is this service that, let's say you want to use resources outside of AWS, right? So I want to create a GitHub repository. I use Ops.Genie. I want to create Ops.Genie users. I maybe want to create PagerDuty queues. I want to do something that's not AWS native. You could do this. You can create a Lambda script that would do that, but that's just doing a lot of glue and tape on things. Kind of doesn't work to the best of its abilities, right? There must be a better way to do it. So CloudFormation registry and CLI is this kind of a feature of CloudFormation that allows you to build, basically natively build CloudFormation resources inside of AWS account, right? So you build this thing as you would define a resource in CloudFormation. So like AWS : S3 : bucket, you can define something, Darko : unicorn : factory, right? You can do something completely different And you can create all this logic behind it. You can basically create anything. You can manage, GCP and Azure resources with this easily. Right? So there's already like a bunch of third-party providers, Datadog, New Relic, Spotinst, Dynatrace, Atlassian, all of these lovely folks you see here already have their providers available, which you can just import into your AWS account easily. So there's a couple of things you need for this, right? So the first thing you need, as with a lot of things I talked about today, you need some CLI. You need some command line interface. So there's 3 versions of CLI as of today, as of the 2nd of April today. There's the Golang plugin, right? There's the CloudFormation Java plugin, and there's also the Python plugin, which is still in preview. So it's still you need to give it a moment there. So all of these are installed using pip, but it's important why we use these things, because if you want to write your logic in Golang, you need to use the Go plugin. If you want to write your logic in Java, you need to use the Java plugin and Python setting. So this really depends on which language you're going to use to make your custom resources. And mind you, there is an effort built into creating these things. It's not just a matter of fire and forget. It takes some effort to deploy these things as well. To write the code, and you'll see later on. So modeling your new resource. How do you model that new resource? So you have to create this model or a schema that will define what properties you can define on that thing, what kind of permissions you need. So for example, in this case, I'm creating a unicorn factory. And that unicorn factory can take a UID as a property, a name, a superpower, and a family for my unicorns, right? These are the parameters you can pass on to this CloudFormation resource once you create it. Also, you can define some specific permissions for a specific handler, right? So if you need some sort of permission to create, read, or update, right? For those specific handlers, you can define them here as well. I don't need anything because in this example, I'm actually invoking a third-party REST API that I'm just creating a unicorn. So time to work on those handlers. And this is where the most complex part of CloudFormation registry comes in, is you need to actually, sit down, warm that chair, as they would say, right? And write some code. So my handler, for example, for creating a unicorn in my API is basically I'm making an API call here to an API endpoint. So I have a function called create. It's written in Golang that just takes some parameters, right, that you pass it on, and runs an API request to an endpoint that I've defined later as one part of my code, right? So this is it. This is how you do it. Great. You have to do a read one as well. Maybe if you want to read information from it, if you want to delete it, how would you make which API call does this? Again, this can be anything. As long as you can follow the proper return responses and you can manage the parameters, you can literally run any piece of code here that will do something or not, right? Did somebody mention tests, right? I've been talking about tests today a lot. So let me just talk about a few testing ways you can do this, because there's also important ways to it's important to test your code even when it comes to these things before actually provisioning all that. So to test your code, right? So to test my resource, my newly created resource, without pushing it to AWS, I can test it locally with SAM local, or serverless application model local. So basically what it will do, it will generate a Lambda script running in a Docker container locally on my laptop, and it will emulate CloudFormation, and it will try to create a test, basically a unicorn here with my custom resource, and it will just basically spit out, yep, it's successful or not. So it basically emulates kind of CloudFormation in this case. Runs it all locally. I don't have to push it. I don't have to push anything, beyond. So it should pretty much work. So now what, right? After we have tested, we're super satisfied. Well, upload, right? I think it's time for us to upload our code. So how do you upload? Well, CFN, that's the new command line utility, right? CFN submit -v. That's it. It takes a while, so it creates a couple of things, creates a stack for permissions. It creates all the different things you might need there as well. It does that all from the command line. And next time you log into your CloudFormation template, voila, right? It exists there already. You can see the Unicorn Factory present there as a resource type. As a resource type, you can see it all there, right? Simple as that. You can then use it in your CloudFormation template as you go along within your account and your region. Okay, last slide, I promise. Well, 2 slides left. Takeaways. A couple of takeaways here, right? One, best practices start in your editor. Use the proper tools, use the proper plugins, get those linters, get the things you need to do it in the editor and around the editor, right? Treat infrastructure as code as any other code. So it's not special. It's the same thing as your application code. Apply all the best practices you can do for your application delivery, such as pipelines and all those tools. Use it for infrastructure as code. Finally, use testing tools for any framework you write your infrastructure in. I have mentioned just a couple of frameworks here, but believe me, all the others have something similar as well. Use them. They will help you immensely, especially if you're starting out. Thank you very much. This has been me, right? Thank you very much for having me here. Please feel free to reach out on any of these social media platforms. LinkedIn, Twitter, I even have Facebook. You can find me on Twitch. I stream there some AWS content. And yeah, I guess I will be answering some questions now, I think, somewhere.
Absolutely. Darko, thank you so much. That was really informative.
Welcome.
Super presentation. Thank you.
Thank you.